So let's look at some practice. What is the molarity of a solution containing 3.4 grams of ammonia, and the molar mass is given here as 17.03, and the units are grams per mole, in 200 mils of solution? Go ahead and pause the slide, see what you get, and then I'll go over it. So, as always, we write out what we're given: 3.4 grams of ammonia, 200 mils of solution, the molar mass of ammonia is 17.03 grams per mole, and then we want our molarity. So I always write out the definition. Molarity is moles over liters of solution. Our 200 mils of solution we can change into liters using our railroad math, but an easy thing to remember is to get from milliliters to liters, all we have to move is our decimal 3 places to our left. So 200 milliliters is equal to 0.2 liters. So now we can plug in down here 0.2 liters. Now in the top part we need moles of ammonia, and we're given mass, and to get to moles from mass we've got to use our molar mass. So 3.4 grams of ammonia, do our railroad math, 17.03 grams of ammonia. Down here, that's equal to 1 mole of ammonia. And our grams of ammonia cancel out. The units that we end up with are moles of ammonia. And my calculator, rounded to 3 sig figs, is 0.200 moles of ammonia. So we go up here, 0.200 moles divided by 0.2 is going to be 1 mole per liter, or 1 molar. So if you got that as your answer, give yourself a big pat on the back. All right, let's look at another problem. This is example 13.4 from your text. How many liters of a 0.114 molar sodium hydroxide solution contains 1.24 moles of sodium hydroxide? So the first thing we always do is write down what we're given. 0.114 molar, which is units of moles per liter, and we're also given 1.24 moles of sodium hydroxide, and what we want is liters. If we go back to the equations that I first wrote out about molarity, we see that liters is equal to moles divided by molarity. So all we have to do is plug in the correct values. I'm given 1.24 moles of sodium hydroxide, and that's over the molarity, which is 0.114 moles of sodium hydroxide per liter. So if I look at my units, my moles of sodium hydroxide cancel out, and my liters come to the top, and when I divide 1.24 by 0.114, I get 10.9 liters. So if you got that, give yourself a pat on the back. You always want to make sure that your units cancel out, and whenever I'm doing these type of problems where I'm using one of the three equations that I've given you, molarity equals moles over liter, or moles equals molarity times liter, or liters equals moles divided by molarity, yeah. If you're using any one of those three, I always use my units of molarity as moles over liter, as I did here, so you can see how everything cancels out. And let's look at one more practice problem. Determine the mass of calcium chloride, and here's the molar mass of it, in 1.75 liters of a 1.5 molar solution. So the first thing we always want to do is write out what we're given. I'm given 1.75 liters. I'm given the molarity of the calcium chloride, 1.5 moles per liter, and I'm also given the molar mass of the calcium chloride. And we want the mass. So how can we solve this? Well, if we look back at our equations, I don't have one that gives me that lets me solve for mass, but I do have an equation where I can solve for number of moles, and that's my molarity times my volume. So if I have 1.5 moles of calcium chloride per liter, and I multiply that by my liters, which is 1.75 liters, then I can see, and let me just use a different color pen here so we can see exactly what's happening. I can see that my liters cancel out, and the units that I'm left with are moles of calcium chloride. And then I multiply these two values together, and I get, where's my pen? I've got to find my pen. Here it is. Okay. I get 2.625 moles. Now I'm not quite done yet because my problem wants to know how many grams I have. What's the mass? So I know I can get from moles to mass using the molar mass. And the slide was nice enough to give me the moles, or the molar mass. So if I have 2.625 moles of calcium chloride, my moles cancel out, and then I multiply across 2.625 times 110.98, and let me write my, where's my pen? Here's my pen. Here's my answer, 291 grams of calcium chloride. And that makes sense because I have about 2.5 moles. Each mole weighs a little over 100, so more than 2.5 should be something in this area. So 291 grams of calcium chloride.